Hello, I'm Matthew Winnick, and this is my math CCT. The question is, are post-up big men valuable in the NBA? So my thesis is that post-up big men might not be as important in the NBA as we originally thought. And as there are 5 positions in the NBA, they're all very important to making a team as great as it can be. The positions are point guard, shooting guard, small forward, power forward, and of course center. And they're all very different, but very vital to a team's success. That means, however, in the past few years, many basketball players that are big men, so the power forward and center positions, have been sent to the bench. Players known for their scoring on the inside, and that are not necessarily skilled shooters or skilled defenders, are playing a lot less in favor of players with a more modern style of blocking shots and shooting threes. Guys that used to score 20 points per game, or even some players that are all-stars, and those players include Al Jefferson, Greg Monroe, and Zach Randolph, seem to be losing their purpose in the league. Is this just a trend, or are post-up big men truly less valuable in the NBA now than they used to be? So for the purpose of this report, we're going to define who a post-up big man is. Post-up big man is a player that primarily plays the power forward and center positions. They have to be over 6'6" tall, and they have to play in the NBA as of 2016-17 season. A player who has registered a block percentage below 4% is also included in this list, along with players who not only do that, but shoot below 30% from three-point range with a minimum of 10 attempts. Now, on the contrary, the people we're comparing are the modern big men, and they are players that are also power forwards and centers, also over 6'6", also currently playing the NBA as of 2016-2017, but they have a registered block percentage that is over 4%, or, not and, but or, they shoot above 30% from three-point range, also with minimum 10 attempts. So how will my thesis be determined? That will originally be used with the website basketballreference.com, and I was able to determine 4 variables that will be compared with 30 of the top players of each category, the post-up and the modern big men. The Y variable, which is the largest determining factor because it keeps on getting compared, is the player efficiency rating, and that shows a player's overall skill. 3 more variables, win shares that show the player's effect on a team's victories and losses, along with defensive box plus minus, which shows a player's defensive ability more or less, along with value over replacement player, which shows how the player compares to the NBA average. The spreadsheets will be completed in Microsoft Excel, and all of the graphs will be completed in the application Fathom. Not to mention, all statistics used for this report were taken from the 2014-15 season and the 2015-16 season. Now, here are some of the definitions of the statistics that I'll be using. First, my Y variable, the player efficiency rating, or PER, is a statistic that was created by NBA statistic king John Hollinger. This stat is sort of an all-in-one rating, and it takes almost every single statistic, so you can name it points, rebounds, assists, minutes, percentages, everything you can think of, and it boils it down to a per-minute basis. It adds points for positive statistics and subtracts points for negative statistics. The stats are also adjusted for the team that the player is on and the pace that they play at. The average player efficiency rating is 15. The second statistic, my first X variable, is win shares, and it was developed by Bill James, who was originally a baseball statistic guy, and this statistic was actually made for baseball originally. But it was recently converted to basketball as well, and it uses many on-court statistics to show how many wins a player gets for a team. So if a team finishes with 60 wins, you'd be able to see how many wins are directly attributed to that specific player. Next, we have defensive box plus minus, or DBPM, and that's on my second X variable. An advanced stat that was recently created. Box plus minus is a statistic that takes in the player's numbers and how well his team does while he's on the court. But defensive box plus minus, you have to find that by calculating the offensive box plus minus and then subtracting it by the box plus minus. So lots of box plus minuses going on to calculate that. Lastly, my last X variable is value over replacement player, or VORP, or VORP. VORP takes in the player's average BPM, which is box plus minus, and it compares it to what's considered the average NBA player's ranking. This creates a stat to show the value versus a random average player in the league. So right down the middle, is he better or worse than the average? Now we're going to move into our one variable statistics, and we're going to see what graphs were created. First up, we have the one variable statistics for the player efficiency rating. Here we have all our statistics there, and we've chosen mean and standard deviation for our two measures in order to calculate the measure of essential tendency and the measure of spread. As you can see, there is only one value near the bottom, near the end of the PER histogram that you can see is about 13, whereas all the other ones are approximately 14 and higher. And as you can see by the box plot, it's relatively evenly spread, although the median is a bit closer to the left side of the box plot than the right side. However, not too much going on. That's really weird. No crazy outliers, and the highest frequency is 5 on the histogram for the post-up big men. Now, as we look towards the modern big men analysis, we can see that we chose median and IQR as our measures for these specific graphs. You can tell the evident outlier that lies in both the box plot and the histogram, and that is that one PER rating at approximately 31. Only one player has this, and it's so far off of the box plot that only a point is shown, just a dot, not even the line that normally goes through a box plot, as it is so far away from the line. Now that also means the median is much closer to the right side of the box plot than the left side, as that one point really makes a big difference. Here the biggest frequency is also 5, but it's all the way up at 22. Next up is the one variable statistics for the win shares. Post up big men first, and we can see that we've chosen the mean and standard deviation as our measure of central tendency and measure of spread. Now, there's a very high frequency, as you can tell by the histogram, of almost 8 for the win shares at 4. So you can see almost all the win shares are approximately at 4, and the rest are scattered around, with one small outlier at around 10.5. Now this means that due to almost all of the frequency beginning at 4, which is one of the lower numbers, the line on the left side of the box plot is very small, and therefore sort of changing the IQR by not having the Q1 very similar to the median because it's very close together. That's why standard deviation was chosen in this case. Next up is the modern big men analysis for the win shares, and you can see we've also chosen mean and standard deviation for our measures of central tendency and spread. Not too much crazy going on in this graph. However, the win shares also begin at approximately 4, just like the post-up big men, and you can see that once again in the box plot, that line is significantly shorter than it would be in a normal box plot, and it's much closer to the median, meaning that the IQR would also be ineffective in this graph. Next up would be the defensive box plus minus statistics, and this is for the post-up big men. As you can see, we've once again chosen the mean and the standard deviation as our measures of central tendency and spread. You can see on the histogram that there are numbers that reach all the way almost to 3.5 and 4, but also numbers that are almost exactly 0. It's very spread across, and there's a couple outliers that are higher above 3, as almost all of the data points are below 2.5. The median, however, seems very normalized in terms of the middle of the box in the box plot, and the lines are not too different, although the line on the left is very close to the axis, which is 0, because there are some points that are very close to 0 for the defensive box plus minus stat. As we move along to the modern big man analysis for this statistic, we can see that mean and standard deviation are both the same measures that are chosen for these graphs. And you can see that there's also defensive box plus minus stats that reach almost 0 in this histogram for the modern big men. However, unlike the other one for the post-up big men where there were barely any over 4, there are multiple that stretch past 4 and even past 5 all the way to 6 for defensive box plus minus, but the frequency is still highest closer to 1, similar to the post-up big man. And once again, just like the post-up big man, the box plot is very similar, as the median line is close to down the middle and there's not too much of variance in the lines in the box plot. Now our last statistic for the one variable statistics is value over replacement player, or VORP, and for the post-up big men we have once again chosen mean and standard deviation for our measures of central tendency and spread. And similar to the defensive box plus minus for the post-up big men, there's only one or a couple of values over 3, and almost all of them are in between 0 and 2. However, there's only one statistic that is below 0.5, and it is very close to 0. This could be considered an outlier, but there's also the one over 3.5, which is even more spread out from the median. This also shows up in the box plot where the line on the right is significantly longer than the line on the left due to that one point over 3.5, despite only one other point being over 2.5. Lastly, for the one variable statistics, we have the VORP for the modern big men, and for here we've chosen the median and the IQR, as we can see that there aren't very many outliers here in this graph, and it ranges all the way from 0 to 6 with no major spaces in the middle. We can see that the highest point of frequency, which is 6, for the VORP graph in the histogram, is shown, and it's just past 2 in terms of the value for the VORP. As we can see from the graph, the median is very centered and the lines are not too dramatically shifted. Now lastly, we have a one variable statistics comparison, and this is a quick comparison on all of the values for each statistic on the post-up side and the modern side. And it's very evident here that the numbers for the modern side are significantly better than the numbers on the post-up side. As we can just slightly look at the mean perhaps as a good comparison tool. For PER, modern wins 20 to 17.3. For win shares, modern wins 7 to 5.6. For defensive box plus minus, modern wins 2.5 to 1.66. And for VORP, modern wins for 2.34 to 1.5. So it's shown here just in the mean that modern has won in all 4 categories in terms of the higher value per player, as a mean is what that calculates. It's the average between all players. Now moving on to two variable statistics. Now I'm just going to mention, this is a bit of a disclaimer beforehand, that two variable graphs are not two variables comparing each other, but rather two variables graphs comparing with each other. So that might sound confusing, but I'm going to give an example to clear it up a bit. So this means that the post-up big men player efficiency versus win shares graph is not comparing their own player efficiency and win shares, but rather comparing the whole graph, player efficiency and win shares, against the graph of the modern big men player efficiency and win shares to compare effectiveness. If you're still confused, then you'll figure it out right about now as I move on to the next slide, comparing the player efficiency and win share graphs for both the post-up big men and the modern big men. Now in terms of the R values, they're both similar. The post-up big men has a less of a correlation at 0.53, and the modern big men has an R value of 0.65. Now these are both moderate positive correlations, so not very strong correlations. However, they are both correlations that are moderate and not strong, yet not weak. What is evidently shown if you were to look deeply into these graphs is that both of the scales are different, as the x-axis on the post-up big men only go to 12 for win shares and 16 for the modern big men. Also with player efficiency rating, it goes all the way up to 32 for the modern big men, yet only goes to 22 for the post-up big men. So although these graphs may look similar, it is evident that the modern big men clearly have higher rankings in both of the statistics. What's also shown is that outlier that we saw in the one variable statistics for player efficiency rating that is all the way up approximately 32 and is also first in win shares. This means that this correlation gets a little bit stronger as it's going higher up and sort of has more of a line that makes sense in terms of the parallel line that is needed here in this graph. If you were to compare these two graphs, you would see lots of similarities at first glance. However, looking at the scales, you would notice that they're quite different. Next up is a comparison between player efficiency rating and defensive box plus minus. Now, believe it or not, both of these R values are the exact same for the post-up big men and modern big men. They're both at 0.14, or weak positive correlations. But once again, we have to look at this with a more in-depth look, as we'll see here, that the player efficiency rating line only goes up to 22 for the post-up big men, and all the way up to 32 for the modern big men, along with the defensive box plus minus that only goes to 4 for the post-ups, yet 6 for the modern big men. So when we look at the graph and we look at the line, it looks like it might be starting from approximately the same place. However, when we look a little bit deeper, the line on the post-up graph starts just over 18 player efficiency rating, and the player efficiency rating line starts on the modern big men graph just at about 22. So although it looks like the same line in terms of the line being very horizontal, one is a lot higher than others, not showing more of a correlation, but showing a higher rating in terms of the statistics. There's not much to be said about the correlation, as you could hear, both of them were weak, and there's not much to say that this made a big difference. So a conclusion we can make about this section here is that neither defensive box plus minus really affects player efficiency rating on both sides. That means that you could be a pretty bad defender and still be effective, or you could be a very good defender and not be as effective as a post-up player. Lastly, for the two variable statistics, we have player efficiency rating and VORP. Now, once again, both R values are very similar, as the R value for the post-up big men are 0.45, and for the modern big men is 0.49. Once again, both moderate positive correlations. And we can tell here that there is a correlation between VORP and player efficiency rating, as we can see that normally, for the most part, the higher the player efficiency rating, the higher the VORP. And this is shown especially in the modern big men, as almost all of the bottom points correlate with the bottom PER points. This is similar in the post-up big men scatter plot. However, what is found in both of them is near the middle of the graph is sort of all over the place. There are middle of the graph PERs that are very high in VORP, and they're especially in the modern big men graph, as you can see, the second highest VORP is just in the middle of the pack for PER. And for the post-up scatter plot, you can see that some of the highest PERs are also very low in VORP. So although they might not have the highest correlation, they both make sense in terms of correlation from especially the top and the bottom of the graphs. So, in conclusion, what did we learn? Well, after many graphs and comparisons, I think it can be determined that my thesis was correct and that post-up big men are not as valuable as the modern big men in today's NBA. This was shown throughout many points in the presentation, including the one variable statistic graph comparison slide, where each median, mode, mean, IQR, and standard deviation were compared with one another for each stat. And I'm going to go right back to that slide real quick, and if we want to give a quick look here, we can pause the video and see that every single statistic for every single measure is higher on the modern. So if you want to take a quick look at that, see that I'm right, I promise you. But if you don't believe me, I will show you. There's one or two that are tied, but there's none that is higher in the modern, in the post-up against the modern. So we're just going to head back here. So this means that the higher values for the modern big men graphs show that they're better players in all aspects of the game. We also learned that in each two variable statistic graph, the scales were switched in the modern big men graph, showing that despite the graphs looking similar, the modern big men graph was always superior over the graph of the post-up big men. So just some concluding remarks. This experiment went very successfully, I feel, as my thesis was proved correct, and many interesting things we learned from the big men in the NBA. For further research, more players could be included in the statistics for a wider spectrum of results. Another research that could be done is going further back, perhaps 20 years, to see if the same statistics were found between the post-up big men and the qualifications of the modern big men. So we're calling it a modern big men, but if you go back 20 years, where there probably aren't as many people that could shoot three-pointers or block a lot of shots, does that mean that they were more effective as post-up big men? Would it be the opposite way around? And that would be another thing that I could check to see if this was a true fact for just now or has always been a fact in the NBA, and people are just starting to realize it now. So thanks for watching my video. I hope you learned a lot about big men in the NBA, and hopefully you learned as much as I did and realized that I'm very smart as my thesis was correct. Thank you very much for watching.